Okay, let's continue training by solving these training exercises. Training exercise 2 is also establish the following. We have to establish this identity that says that cosine power 4x minus sine power 4x should be equal to cosine squared x minus sine squared x. Weird, huh? How could this happen? Let's see how this can happen. Again, as I told you, I will name this side 1 and this side 2. And all what I have to do is to prove that side 1 is equal to side 2. So let's start by the first side. I have that cosine power 4x and sine power 4x are separated by a minus sign. Then I can apply the difference of two squares identity. Notice, we are using the identities of factorization and expanding in trigonometry. Okay? So I can write it like this. Cosine power 4 will be divided, this power 4 will be divided by 2, then I will get cosine squared x plus sine squared x. As you know, the difference of two squares will give me a plus b. If you remember, a squared minus b squared will give me a plus b into a minus b. So if I put power 4 instead, a power 4 minus b power 4, I will get a squared plus b squared into a squared minus b squared. And thus I'm going to continue. So I will get cosine squared x plus sine squared x into cosine squared x minus sine squared x. Again, let's remember the identities that say cosine squared x plus sine squared x is 1. So I can simply replace this identity by 1. I can put 1 instead of it, and here we have a multiplication sign, so definitely I will get cosine squared x minus sine squared x, which is equal to the other side that I named 2, and thus the identity is verified. Okay, let's see what we have in the next slide. Again, establish the following. I have to prove that 1 minus sine x over cosine x is equal to cosine x over 1 plus sine x. So all what I'm going to do here is to cross multiply. So I'm going to cross multiply. Whenever I see a fraction, all what comes to my mind is to cross multiply them. So I will get that 1 minus sine x is going to be multiplied by 1 plus sine x. And because here I'm using the two sides together, okay, I didn't start by a side to reach the other side. I'm using both sides together. I'm going to have an equal between them. I should put a question mark on this equal because I'm verifying an identity. I'm establishing something. I'm making the proof for this. So I have to put a question mark on this equal sign. What is the other side? So I have 1 minus sine x into 1 plus sine x. Then I should multiply these together. So I will get definitely cosine x times cosine x, which is cosine squared x. So again, I have to use the difference of two squares that says a minus b into a plus b is equal to a squared minus b squared. 1 is in place of a and sine x is in place of b. So I'm going to get 1 minus sine squared x. Okay, because 1 squared is 1. So I don't have to put it 1 squared. It's enough to put it 1. Is that equal? I'm going to establish it. Is that equal to cosine squared x? Let's think. Let's remember the identities. And here are the identities. Cosine squared x plus sine squared x equals 1. Sine squared x equals to 1 minus cosine squared x. And cosine squared x is equal to 1 minus sine squared x. So I got it. That's true. Cosine squared x is equal to 1 minus sine squared x. So that's true. But if some did not remember these identities, all what they can make is to take sine squared to this side, and then they will get that 1 is definitely equal to sine squared x plus cosine squared x, and that's also true. So either you can stop here and say that this is verified because definitely cosine squared x is equal to 1 minus sine squared x, or you can continue. If you didn't remember this rule or this rule, you have just this rule in your mind, so you can continue by taking sine squared x to the other side, and thus you will get that 1 equals sine squared x plus cosine squared x, which is true because it is 1.